For, forever, physicists have been chasing the ultimate prize, a single beautiful theory that explains absolutely everything. But what if that whole quest is, well, doomed from the start? Not because of bad physics, but because of a hard limit in logic itself. Let's get into it.
I mean, this is the big one, right? A master formula, a theory of everything that unites the entire cosmos, from the absolute smallest quantum particles to the biggest superclusters of galaxies. It's the holy grail of modern physics.
So to really get why this is such a monster of a challenge, we kind of have to take a step back and see how our picture of reality has completely changed over time. It's been one heck of a journey, from things we can touch to ideas that are just deeply weird and abstract.
It all started with Newton's universe, which was, pretty straightforward. It was like a giant clock, predictable stuff moving through a fixed space and time. Then Einstein comes along and just blows that all up, weaving space and time together into this single bendy fabric. But just when we thought we had a handle on things, quantum mechanics showed up and revealed a universe built on pure random chance. And that's pretty much where we are now, trying to find this thing called quantum gravity to finally get these two stories to match up.
And this brings us to the great civil war in modern physics. We have these two incredible theories that are just flawless in their own domains. General relativity is the undisputed king of the big stuff: planets, stars, galaxies, you name it. And quantum mechanics? It's the master of the bizarre, fuzzy, probabilistic world of tiny particles. The huge, glaring problem is they absolutely hate each other. They don't speak the same language.
When you go to the most extreme places you can imagine, like the dead center of a black hole or the very first instant of the Big Bang, and you try to use both theories at once, they just break. They spit out gibberish, these infinities that physicists call singularities. Now, that doesn't mean physics is wrong. It means our fundamental map of reality, our whole idea of spacetime, is missing a crucial piece.
This huge roadblock has led physicists to a really wild, radical new idea. What if spacetime itself isn't the bottom floor? What if reality is actually built on something even deeper? Something like pure information.
This leads us to the mind-bending it-from-bit idea, which comes from the brilliant physicist John Wheeler. The concept is that every particle, every force, all the physical stuff is actually constructed from bits of information. In this view, information isn't just how we describe the universe, information is the universe.
Okay, so if the universe is made of information, then that theory of everything we're searching for wouldn't be a set of equations on a whiteboard. No, it'd be more like a master algorithm, the ultimate source code that's running the entire cosmos.
But, and this is a huge but, right as physicists started thinking about the universe this way, they slammed face first into a wall. And this wall wasn't made of physics. It was made of pure, undeniable logic.
You see, for any algorithm to work, it has to be what's known as a formal logical system. Basically, it has to be a perfect, super strict rulebook with a fixed set of rules you can use to prove things about the universe.
And this is where the trouble starts, thanks to a logician named Gödel. He proved something completely staggering. Any powerful and consistent rulebook is guaranteed to be incomplete. It will always contain statements that are true, but that can never be proven true using only the rules inside that book. It's like having a math book that contains true equations it can never, ever solve.
Then there's Alfred Tarski, who threw another wrench into the works. He showed that a rulebook can't even define what truth means for its own statements. How can a system be the ultimate judge of its own truthfulness? It can't. That's a logical paradox, like trying to lift yourself into the air by pulling on your own boots.
And the final piece of this logical puzzle comes from Gregory Chaitin. He established a hard limit on complexity. Basically, no rulebook can ever prove a truth that's more complex than the rulebook itself. An algorithm that fits on one page can't possibly prove a theorem that takes 1,000 pages of logic to write out. Every system has a complexity ceiling it just can't break.
So, what happens when you put these three logical bombshells, Gödel, Tarski, and Chaitin, all together? The conclusion is just inescapable. A purely computational theory of everything, a single master algorithm that explains all of reality, is a logical impossibility, full stop.
So, is that it? Game over? Is physics done? Not even close. The very same paper that lays all this out also proposes a fascinating way forward. We just have to start thinking outside the algorithmic box.
They suggest we need a meta-theory of everything. Think of it like this. A standard theory is like a computer program, trapped by its own code. It can only do what its rules say. But a meta-theory adds something else to the equation, a layer of what you might call non-computational insight. It's the difference between a calculator which just follows rules and a mathematician who has a genuine aha moment and sees a truth the calculator could never find.
So how would this actually work? Well, you start with the standard computable rules of physics we already have. Then you bolt on what they call a truth predicate. Don't get lost in the jargon. Just think of it as an oracle that sits outside the main system. It's not limited by the algorithm's rules, so it can see those Gödelian truths that are unprovable from the inside. It then just certifies them as true, completing the picture. What you get is a theory that marries pure computation with something that feels a lot like real insight.
Now, this new framework doesn't just reshape physics. It has a jaw-dropping implication for one of the most popular questions out there today. Are we living in a computer simulation?
The logic here is beautifully simple. A computer simulation, by its very definition, is an algorithm. It's just code running on a machine. But if this meta-theory is correct, our universe contains truths that are fundamentally non-algorithmic. They can't be computed.
The difference is stark. A simulation is a closed box. It's limited by its own code. It can only ever produce results that are derivable from its own rules. Our universe, on the other hand, seems to be fundamentally open. It contains objective truths that lie beyond computation, truths that no algorithm, no matter how powerful, could ever discover on its own.
And that brings us to the final, shocking takeaway. According to this work, the simulation hypothesis isn't just improbable. Because a simulation can't contain the non-computational truths that are present in our reality, it's logically impossible. Our universe simply has features that a computer program cannot replicate.
So this all leaves us with a truly profound final question. For centuries, we've asked if reality is made of its, physical matter, or bits, pure information. This theory suggests the answer is neither. It points to a reality that might be grounded in something else entirely, a kind of non-algorithmic insight, a universe that doesn't just compute, but in some deep and mysterious way, understands.